All right, welcome back to Lesson 2, Velocity, example number 2. In this example, we're going to be talking about a car traveling down a road, and it's going to be traveling during two time periods at two different speeds. It's asking us to solve for the average speed and the average velocity. Let's jump right into it here. So, let's say, I'll start with blue, why not? And my line tool. This car is going to be traveling north at 77 kilometers an hour for 3.8 hours. So I'm going to start here, and I have my line tool selected, so there we go. It's going to be starting here and traveling north. Okay, the velocity on this is 77 kilometers per hour north. So 77 kilometers per hour for 3.8 hours. Okay, so already I think we should be able to see that we can find a distance here. Then what does it do? It then travels 49 kilometers per hour south for 2.6 hours. Okay, just judging how both those values are smaller than our initial values, I'm guessing it's not going to surpass itself. So we're going to draw a second line on here. And we're going to say this travels down, probably about that far, sure. And its rate of travel is 49 kilometers per hour. For a time of 2.6 hours. Great. Okay. Now, we have a few things that we can discern here. We can solve for the distance that both of these travel in this time. We also have a total amount of time. All right. I think what I'd like to solve first in this problem is just to solve the distances that these lines represent. So I'm going to turn this back to blue, and we're going to solve the first leg here. So we'll call this leg 1. Let me put a little number symbol on there. Leg 1, and what's our formula for distance? Distance is equal to velocity times time. I should also note that this is going to be heading north. Okay, let's plug some numbers in here. Distance is equal to our velocity, so 77 kilometers per hour times 3.8 hours. Sure nice of them to keep it in useful units for us here. That works out to, for me, 292.6 kilometers. 292.6 kilometers. So we can even add that on here. Say that this is 292.6 km. All right, then in red, we have leg number 2. Leg number 2. And this is south. Same thing. D is equal to VT. So distance is equal to 49 kilometers per hour times 2.6 hours. So our total distance traveled on the second leg comes out to 127.4 kilometers. Great. So we can add that in here. We're going to say that's 127.4 kilometers. Now, what do we do with that? Well, first, I'm going to average it. I'm going to find the average speed first, because it's what the question asks for first. So let's do average speed in green. So average speed. This is a little hard to see. I'm going to darken this up a little bit. Average speed. That's a little bit better. Okay. Well, what we know is that speed, being a scalar vector and direction doesn't matter. This is what we're going to be learning in the lesson anyways. We can say that speed is going to be the total distance traveled, meaning if we were headed to Red Deer, we would count the distance to Red Deer, and if we headed back, we would count the distance back. Then we're going to divide it by the total time, and we'll have our average speed. Great. So let's do that. We can say that our first distance is going to be 292.6 kilometers plus our second distance, which is 127.4 kilometers. And we want to divide it over, or divide it by our total time traveled. That's one thing I think many people are going to get caught on, is not dividing by the total time traveled here, right? So it's our average speed for the whole trip. So it's going to be 3.8 hours plus 2.6 hours. If we want to throw all these terms in brackets, so we solve for them first, sure. Okay, let us figure that out. Our average speed is equal to, I end up with a value of 66 kilometers per hour. All right. Now, if we want to solve for average velocity, maybe we'll do that one here in magenta. So average velocity. Well, it's going to be the difference in the distance traveled here, because really we're trying to find this distance, right? Because we're cutting across from here. This is our displacement. That's not going to be a very large value. So let's find that. We have positive 292.6 kilometers. So 292.6 kilometers. And we're going to subtract the second value, which we solved down here, 127.4 kilometers. All right, so this is going to give us the difference in distance in this trip. And again, we're going to divide this term by the total amount of time of this trip. So same thing, it's going to be divided by 3.8 hours plus 2.6 hours. Okay, let's put all these terms in brackets. And our average velocity, if we were to work this out, I get this coming out to about 26 kilometers per hour. It might not come out as such a round value, but if you look at the question, we only have 2 sig figs to work with. So we have to round our final answer to 2 sig figs. Put a box around that. I'm going to pop back to green. I'm going to put a box around that because these are both our final answers. And we'll call it good.